Ryan with Miss.Geek here, and tonight I'm going to show you, it's tonight for me. Today I'm going to show you a video. I'll show you something that I put together that I think is pretty cool. I'm really excited about it, and I'm sure you'll be able to tell because I won't be able to stop talking about it. But I've come up with something that I think is going to help me a lot and maybe even help others. And that is when it comes to prototyping. Now, if you were one of the people who responded to a post that I did on, I think the BitX20 group, the QRP Labs group, QRP Tech, and maybe another, asking about what size Manhattan pads you used, this is why I asked, because I wanted to get a survey so that could put something together that would be useful for everyone. The most common size, by the way, was a 1/4 inch. So let's talk about prototyping. And I'll show you a couple of methods that people often use and talk about some methods that people are using. And then I'll show what I've come up with. Okay, so prototyping. Now in ham radio homebrewing, prototyping is most often done with the Manhattan board method. And if you've never used this, it's real simple. You take a board such as this and a blank one. Of course, this one's been worked on a little bit, but take a blank board and then cut it into strips and then cut those strips into pads. And then you glue those pads down to a board to build a circuit. And the ground plane is real nice because RF loves a ground plane. And so you have a solid ground plane here, and then you can solder things directly to a pad or to the ground plane. And so, of course, the ground plane is shared, and then the pads isolate the components from the ground plane, which is really good. So you can build circuits. This is the leftovers from the DC40 project I did a couple years ago. I've robbed parts from it a little bit, but here it is. It works pretty good. This is a time-proven method, but people have been improving on it for a long time as well. One of the common things to do is to grab a drill bit that's made for drilling out tack welds and drill like 1/8 inch holes, but it's a hole saw basically, just a real small hole saw to make little pads for isolation. So you don't have to cut these and then glue down these square pads. So that's one possibility, is getting rid of these square pads by making an island out of with a really small hole saw. That's one method. Another one is I think QRP Me makes them. They're little Me pads, and they're self-adhesive pads that just stick on, which is pretty cool. And those just are on a little board that they break off, and they're a little tiny 1/4 inch. I think they also sell bigger ones too. So that's one method. Another method that has gained popularity in the last year or two because of the advent of cheap CNC routers is CNC routed islands and circuits and whatnot. Now, I don't know about you guys, but when I work with these, I have a real hard time with the ground connections because you have to heat basically the whole area of copper just to make one little solder. I've also have problems with, and so I ends up with cold solders. That stinks. Of course, I'm experienced at it too, but it's definitely a barrier of entry into this style. At least it has been for me. So that's the way people have been using bare copper boards for Manhattan style building. They call it Manhattan because it looks like a city. In fact, I was showing a friend of mine who doesn't know anything about radio one of these boards. He's like, "Oh, it looks like a city." I'm like, "Yeah, they call it Manhattan style." He's like, "Oh, that makes sense." Anyway, but soldering wires to it and stuff, I have always had problems with. You can see, I used hot glue. Actually, I used super glue on this one, and it didn't stick real well. Anyway, so it's good, but it has its problems. Then there are another type of board, which really are not good for RF necessarily, but are good for prototyping in general. There's these proto boards that are just full of holes. They're through hole. And the problem with through hole for prototyping is that it's through hole. So there's that. And I've built boards with these, such as this. There's a little heat sink on this, but you can do this kind of thing to make circuits, which actually works pretty good, and I'm still going to continue to use this for some things. Of course, I graduated from this to a printed circuit board that does more than what this does, and I just plug in the parts and it worked, which was really nice. But there's been something that's been on my mind for quite a while, and the reason it's been on my mind for quite a while is because of the BitX40. This BitX40 project I've been working on, you can see I'm trying to get it into a case here. A lot of the parts, let's see if we get a good shot here. A lot of the parts in the PA section have been replaced from SMD parts to through-hole parts that I simply bent a little bit at the bottom. Like you can see this one here, it's got like a little L shape at the little feet that I bent into it. And then soldered that directly to the SMD pads, and that worked really well. And if I don't like the value, like this one, I started out with a 2K ohm and ended up at like 310K ohm or 2.1K ohm, and then went down to a lower value. And I would just heat those up with those pads and pull it off and put another one on. And if I was using a through hole, I mean, you guys know how hard it is to desolder stuff from through hole. And so I thought, well, what if you just had a board that was all SMDs? That'd be pretty cool, but there aren't any. Now, I did see some stuff. I started asking around. As many of you know, I'm a writer over at Hackaday. And by the way, Hackaday now has a Discord server that you can join. It's so cool. I was on the Hackaday Discord server, and I mentioned my idea to somebody, and they showed me a Reddit thread from several years ago where somebody did a board that was kind of like what I was thinking, but still not really what I was thinking at all. And so I sat down for several hours with KiCad, which is an open source CAD program designed for designing circuit boards. And I made a board that is nothing but surface mount pads. And I'm just going to show it to you here. And so this is nothing but, so I'm going to zoom in a little bit here, try to get you guys get this into your teeth a little bit here. This is nothing but surface mount here. Now, if you look carefully, you can see on the edge, on this edge and on this edge, so just on these two edges, we'll call it the top and the bottom here, we have spacing for 0.1 inch components or pins, like so. And if you look real carefully, take that off of there. If you look real carefully, you'll see that there's individual pads for all of them. Then you've got these 4 pads right here. These 4 pads are independent. And then you've got these are the 4 square pads. And then you've got this diagonal pad, this diamond shape. And the reason these exist, and I'm going to show you here. In fact, if you look carefully at the diamond-shaped pads, if you can see it, you might notice a via going through there. And that via is just a connection to another layer on the board. And that layer is on the back. On the back, we have a ground plane that extends up to but not into the through-hole parts. So, because these are designed to be able to plug in, to plug in here. And so this whole back is one sheet of copper printed on with solder mask covering it. So if you want to solder to it, you have to scrape the solder mask off. And then there's vias, and each of those vias goes to one of the diagonal pads. So just to show you what that does, those diagonal pads are your ground plane. Oh. Here we go. But these 4 are independent of each other and of everything else. But the diagonals are all connected to the ground plane. If you don't want one of the diagonals connected to the ground plane for some reason, just flip the board over, drill out the via. So how does it work? Well, one of the big advantages with this, one of the disadvantages is it smudges, but one of the big advantages here is that, let me grab something to point with. I had a pair of tweezers around here. One of the advantages here is that when you go to heat up, say, one of these ground pads or any of these pads to solder on, it heats up almost instantly. For example, this ground pad right here. Let me grab this one here. You'll see why in a moment. Try to get some proper light. So if I want to solder to this ground pad, this ground plane, put my tip on, heat it, and I have to really hold it there for a second before it flows onto the solder. Right now I've got a cold solder, and finally it warmed up. It's still kind of a cold solder. I'm not real happy with it, which is fine. This works, but I've always had trouble getting a nice solder there. With this board, 1, 2, solder. And now it's tinned and you're ready to go, because these are pre-tinned basically. Now, just like an SMD component board. So that was instant, and that's because the heat doesn't go through to the ground plane because it's only connected with a via. So you're only heating this little pad. Same goes for any of these pads. You're only heating this little pad, and they don't go anywhere. They don't come disconnected because they're part of the board. So I've soldered some components to this here so you can see how it looks. Got a transistor here connected. And then we've got a decoupling capacitor just thrown on there just for fun to a ground pad. Same with this 4-pin little switch here. It's connected not to a ground pad, you can see, but I've got this capacitor here just jumper between that and one of the ground pads. Actually, no, I do have it. I can't see. No, I don't have it on a ground pad. I apologize. I do not. But by putting it diagonally, I avoided the grounding pad, and so it's not touching that at all. So and that's the beauty of this. These are all spaced at 0.1 inch. So this is actually 0.2 inches between all of these. So everything is 0.2 inches apart. So the center, the corners, well, not the corners, but laterally, up, down, X and Y axis, everything's 0.2 inches apart. So if you have a dip package, you could just raise every other pin and it could be floating, and then solder the others directly to the board. Or you could put it on the edge, props. The options are pretty limitless. How easy is it to solder to? That's kind of the one of the big selling points, I guess, even though I'm not selling these, but one of the big things for me is, like, what about something like this trim, where is it? There we go, this trimmer. How hard is that going to be to solder to this? So what I'm going to do is I'm just going to, first I got to decide where I'm going to put it. And I can just fit it diagonally right here. So what I'm going to do is I'm going to tin this one first. Oops, let me get you into frame here. In fact, let me do this. There we go. It gives me light and gets you into it. So I'm going to tin here. And first I'm just going to plop this on here. I probably should have tinned this first, actually. That would make it a lot easier on myself. There it is. So now I've got it on there, and I just bend it forward a little bit. and do each pad. And now each pad is connected. Looks like the front one's not connected. That's just because I couldn't see it real well. But let's get that in there. There we go. See, that one could use a little bit of help too. There we go. So there we have a through-hole component. I'm sorry about that. We have a through-hole component that's connected to 3 individual pads in a very, very short amount of time. And now I can solder something else to it, and so on and so on and so on, and make a complete circuit. So that's what this is all about. I just wanted to kind of introduce this to the world. This is not perfect. This is the first prototype of the prototyping board. And the biggest problem that I have found just with messing with these is that I did not put enough gap between the the square pads and the diagonals. There's not enough gap there. It's really super easy to get a solder bridge. So you have to kind of test that. So what I'm going to do is I'm going to put in another order for these and increase that gap right there. And these are all drawn by hand with KiCad. It was all, or done not by hand, but it's all done with KiCad. But all the spacing and everything was done by hand and then repeated and repeated and repeated. So you need to put more spacing there. This is perfectly usable as is. I am going to build with these, but for the next round, I'm going to do it. And I'm going to make the Gerbers available after I've done the second round and can confirm that they're perfect. But I would encourage you to try this. Learn KiCad and give it a shot. This took me a lot of hours to figure out, but I think it's going to be worth it. I think it's going to be worth it in the short run, in the long run. So anyway, by the way, these boards were sponsored by PCBWay. I want to let you know. So they have, I've mentioned it in other videos as well. These boards were also sponsored by PCBWay. They love to sponsor makers, and they contacted me a couple years ago, and I said, sure, I'll mention you in my videos and stuff if you want to give me a free product, and they did. Now these 10, I got 10 of these. Let me fix my zoom here. So I got 10 of these. Here's all of them. Shipped to me from China. It would have been $26. So that's only $2.60 a piece, which I think is a wonderful deal. Oh, there's one more thing I wanted to show you. Because of the way I did the spacing on this, check this out. So I'm not going to actually solder it because I don't need this connection. But guys, I could solder that right on if I wanted to. Or like so, or however. Or I could even solder it directly to the board. Like so. So anyway, the idea is this is going to be real versatile. So this video is already running longer than I had intended, but I'm just really excited about this, and I would love your feedback and your thoughts, and let me know what you think. So anyway, that's it. Thanks for watching, and we'll see you in the next video, 73. All right, if you've watched this far, thank you. I'm sorry that it's gone even longer, but I wanted to show you one of the features of this board that I forgot to highlight. So you can see I've got these pin headers in here, and I'm not going full length. I didn't grab one that was long enough, but these don't need to be full length either, by the way, because the whole point of these being here, or one of the features of these being here, and you don't have to use this many of them. You could probably use 4, like 2 on each end, maybe, or maybe even 1 on each end. But let's see if I can do this one-handed here. There we go. Now, solder it up, trim underneath, your board's double size, and all you have to do is just do a jumper between two of the ground pads, and you've got the ground plane connected on both sides. Anyway, just had to share. Thanks again for watching.